Hello and welcome everyone. Thank you for joining us today for our webinar titled Predictive Marketing with AI, Improving Retention Through Predictive Churn. My name is Patrick Moran and I'm on the marketing team here at H2O.ai, and I'd love to start off by introducing our speaker. Scott Peet is Director and Head of Insights and Analytics for the Americas at Aimia, Inc. He is responsible for leading the application and innovation of analytics to help understand customer engagement and identify opportunities to create business impact. Over the past couple of years, he has evangelized the application of emerging technologies such as machine learning and AI through the development of client predictive solutions, customer journey analytics, and the creation of a global analytics workbench. Scott also teaches a data visualization and analytics course at the University of Minnesota. Now, before I hand it over to Scott, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the questions tab in your console. We'll be happy to answer them towards the end of the webinar. And this webinar is being recorded. A copy of the webinar recording and slide deck will be made available after the presentation is over. Now, without further ado, I'd like to hand it over to Scott.
Thank you, Patrick. Well, good afternoon, everybody. We'll be talking about predictive marketing with AI this afternoon, and specifically getting into some tools that we can use to improve retention through predictive churn. Obviously, we've got about probably 45 minutes or so to go through the content, so there's quite a bit of content to cover. We'll be just scratching the surface really on this topic, but a few of the things that we're going to cover in today's agenda, basically talk a little bit about customer churn. What do we mean by churn? How do we define it? We'll also be looking at the business impacts of churn, some of the tools we can use for retention, one of those being predictive churn models. We'll talk a little bit about the business value of the models, some of the insights that you can gain from the process. And we'll also look at using some newer tools, artificial intelligence, in that process, in the process of building a model. And then we'll do a quick demo of driverless AI and kind of show everyone how you can leverage that tool in your model building process and how to assess some of the model results. And then we'll look at one quick case study at the end. And then we'll open it up for questions. So with that, I'm going to dive into the content here. So when we talk about customer churn, what is that? You may hear it with different names: customer attrition, customer turnover, customer defection, all variations of that. I would say, simply put, the way that I would define it is customer churn is the loss of an existing client or customer business relationship, a lack of retention. And that could take the form of maybe an account closure, maybe a subscription cancellation, lack of renewal, or just simply the failure to repeat business. So the business impact on the retention side of things, the opposite of churn, Harvard Business Review actually did a study a while back that showed a 5% increase in retention result in a 25% or more increase in profits. As a matter of fact, if you're looking at, kind of depends on the industry that you're in, but in financial services, I've seen numbers that estimate up to a 95% increase in profits through retention, increases in retention. LinkedIn Marketing Solution has also done a study, and they actually went out to sales and marketing professionals and conducted a survey, and those professionals agreed that better insights and an understanding of the customer is a key contributor to customer experience, improving customer experience. And that 58% of them also agreed that improving customer experience led to an improved customer retention as well. So very, obviously very important to the business, and it doesn't become too difficult to justify a look at predictive modeling to improve these types of results. Now, when we look at insights, that's actually one of the top challenges that marketers face. So gaining the necessary insights is vital to drive their strategic priorities, but also one of the things that they struggle with the most. And so those insights can be used for things like deepening, creating a deeper customer understanding, maybe looking at purchase behaviors, trying to understand market basket analysis, looking at social activities and other types of interactions. It also can be used to improve the overall customer experience. So taking insights that allow us to improve one-to-one relevance with our customer communications and deliver a better overall customer experience. Predictive models can be also used in this process. That can be part of the insight building process, and it can be used across the entire customer journey. We could be looking at ways to optimize onboarding. We might be looking at ways to reinforce growth opportunities or to improve customer retention, which we're going to talk about here today. So when we look at a churn model, a predictive churn model, what we're really talking about is a classification model that's based on historical customer data. And what the model is doing is it's actually using different variables, different features that we use in the model creation process to better understand customer engagement, and then probabilistically identify customers that are likely to churn. So it doesn't necessarily jump right into the classification of churn versus no churn, but it creates a score that we can use on the data science side to tune the outcome that it's predicting based on our individual business. But before we dive into building a predictive churn model, oftentimes it makes sense to look at your customer base maybe more holistically and confirm that the opportunity is really in the predictive churn side of things, and maybe there's not an issue somewhere else in the engagement process. So at Aimia, what we do is we actually start with using a tool that we call our Smart Journey, and that maps customer engagement into a number of predefined categories that we've established. And we use that Smart Journey tool to classify the different engagement stages, to quantify the number of individuals that are in each stage, and then predict engagement levels across each of the different key stages. So what you're looking at here on the left side of the slide is the entry point into these stages. So we might look at the attract phase, bringing in acquisition of new customers. We may have a certain percentage, we're showing 8% that have activated maybe through a first purchase. We may end up with 27% or some number that are engaged in purchasing frequently. We'll have another percentage that will be growing, and then ultimately we'll reach a percentage of the audience that are true advocates and some of your top customers. On the right-hand side are areas that we would be concerned about. So we're looking at realign with a 39% of the audience. That's looking at a decline in activity. So maybe looking at RFM scores, recency, frequency, monetary scores, and looking at some combination of decline. And what we're ultimately trying to avoid is that right-hand bucket. So that 18% that has basically lapsed, that churned, we're not seeing any additional activity, from those individuals. So that's the purpose of the predictive churn model, is for us to identify the right-hand side of this as early as we possibly can. So in addition to classification of where customers currently are, one of the other things that we do with the Smart Journey is we actually will look at each of the individual stages and predict where we believe the customer is going to be in the next behavior cycle, the next purchase cycle. So in this case, we're looking at advocates, your top customers. We've got 250,000 customers that we've identified, representing about 9.6% of the total active customer base, and their spend level is pretty high at $3,500 on average. So it can represent a significant source of business revenue. And when we look to the right-hand side of this chart, we're showing some good things, like there's a certain percentage that will remain engaged, a certain percentage of the advocates that will continue to grow, 60.3% that will remain loyal as advocates, but we see at 21.9% that are predicted to move into realign. So they're going to decline in some way. So one of the key insights that I'd like to point out on this slide is that retention risk can occur anywhere in the customer journey. When we look across the customer journey, it's not necessarily just the early phases. We'll have different degrees of risk throughout the customer journey, but the predictive model can allow us to identify that risk at an earlier stage so that we can take some intervention. We can try to re-engage the customers and prevent the churn. When we build a model, there are some challenges that we typically run into, however. Every industry, every business is going to be different. And so there is some initial consideration that we need to look into. There's some exploratory data analysis that needs to be done. And one of the challenges that we deal with to start in building a model is that we have unlabeled data. So what unlabeled data basically means that we may have customer transactional information, we may have demographic information, but in general, we're not going to have labels that say this individual is churned versus not churned. We're going to have to define that for each business. And in order to define churn for a business, we'll need to make some assumptions around what level of lapse that we're willing to tolerate, or at what point do we want to be concerned with a lapse. So at the bottom of this slide, we're showing a couple of different customers. If you look at the top bar, we're seeing a certain level of purchase activity that's occurring throughout the green bar. And then we reach a point of lapse of activity toward the right. And so our question becomes, how long do we wait before we get concerned? So the arrow that I'm showing at the bottom, the question is has that, both of those customers, have they churned at that point in time? Well, what we find is that it depends on the industry that you're dealing with. If you're dealing with a grocery client, you may be expecting to see that individual on a more regular basis. Maybe they're going to come in on a weekly basis to get more groceries, or maybe a couple of weeks. If they're on vacation, maybe we don't see them for 3 or 4 weeks before we would get concerned. If we're looking at other types of businesses, like maybe a car rental company where the customer is taking an annual vacation, or we're looking at retail shoes, those types of businesses, we may not be that concerned with a month lapse. It may be an entirely different lapse of activity that we would be looking at. So what we typically will see is, in a case like this, if we would have labeled churn at that point that I'm showing the arrow, we would have been correct in the top case, because that individual did continue to lapse and we don't see any further activity. But the customer at the bottom actually did return. And so in building our model, we'll need to look at different windows of lapse, and again, it'll be based on every individual business, and we'll have to tune that for the model that we create. What are some of the other insights and business value that we can get from predictive churn models? Well, there are a couple of additional tools that I'd like to point out. One of them being something called the Cumulative Gains chart. So what you're looking at here is, if you look at the dotted red line, that's going up at a 45-degree angle through the center here, that is what you would typically expect if you're doing marketing campaigns and you're just using a random sample to choose your list. So if I wanted to get, for example, if I was looking to achieve 80% of the gains, maybe reach 80% of the individuals that were likely to churn, I would need to take a sample of about 80% of that audience, a random sample, in order to achieve those gains. If we're using a predictive model, however, that's where the blue curved line comes in. And so the model allows us to be much more efficient in our selection process. And so in this particular case, we're showing that we're able to choose about 38% of the audience to achieve the same 80% of the gains. So we've got a much more efficient way of targeting. What we can do with that insight is we can build customer groups by churn score. So in this particular case, we have created vision tiles. We've got 20 different groups, and we've organized and ranked the members with the highest likelihood to churn at the top. So you'll see that score number 20 at the top. Those are ranked basically, and as you can see in the blue and the red over toward the right-hand side, we can focus on the top 6 or 8 customer groups and get about 88.7% of the overall results. So that allows us to be much more precise with our targeting. We can reduce costs in communications if we're doing a direct marketing campaign or even email marketing campaigns. We can reduce the costs. We also are able to improve our ability to target offers and avoid unnecessary costs, maybe targeting people that wouldn't have churned anyways. We can reduce the risk of alienating customers by sending communications where we don't need to, maybe communications that are irrelevant to the individual. And we can also look for ways to realign customers back into the brand by using this type of insights. A couple of other tools that we can get from the model. The one on the left with the bar charts is basically showing us variable importances. So from a model standpoint, this helps us understand what features that have been created are most important to the model, what it's using to ultimately decide whether or not somebody is at a high risk of churn or not. But it also can provide us some insights that we can use in the organization, maybe operationally. So for example, if you were to look at the variable importances and you see that interactions with an online customer self-service tool was important to the model, then you may operationally look for ways to get more customers involved for that particular tool. Or we might see things like certain combinations of products or certain cross-sell opportunities were important to the models. By knowing that, it can help us change some of the ways that we're dealing with our customers, maybe communications, priorities, that type of thing. The other tool is shown on the right-hand side, which is a decision tree. And that decision tree can allow us to look at any given customer and understand what the criteria was that the model used to make its decision. To decide whether or not the individual was likely to churn or not. And that might help us, again, understand, was it some tolerance for days of lapse, or in this case, we're showing an unexpected sequence order. That was the initial decision point. So that information, again, can help us gain insights into what's going on in the audience and help us determine what we need to do next, I guess. So when we build a model, this is just a very high level of some of the steps that we're looking at, and I wanted to go over this briefly because there's a few of these where AI tools will help us be much more efficient, will save us a lot of time and help us become more accurate. So we go through the process of gathering data. We need to assemble and cleanse the data, get it into a format that machine learning tools could use. That may include some level of data exploration to look at quality concerns or data transformations that may need to be done. And then at some point in time, we get into what's called feature engineering. And feature engineering is basically creating different types of variables out of the raw data that we believe could be helpful in steering the model, helping the model to identify the outcome that it's trying to predict. As part of the process, we also need to go through and choose algorithms. So we'll take a look at a few of those on the next slide. And then we go through a model training and fit process. And then ultimately, looking at the predictions that the model is making and validate the results. Some of the data that we might look at, just as examples, as it relates to predictive churn. As I mentioned at the start, we've got historical data that helps us to better understand the behaviors in our customer base. These are things like purchase transaction information that could be looking at market basket data, what are the customers buying, frequency trends, how that may be changing over different intervals. There may be seasonality that we need to consider. In cases where we have demographic information, that can be very useful, as well as looking at segmentation or performing a cluster analysis to see which groups of customers behave similarly. We may look at redemption activity in the case of a loyalty program. That can definitely be insightful. And then any other forms of interactions. As we know, the customer journey is very much omni-channel these days. There's many different devices that customers are interacting with, from mobile devices to laptops. There may be interactions on social channels, websites, etc. All of that can be an input to the model. Then once we have that data, the transformation steps, the data cleansing, restructuring, model algorithm selection, and then the feature engineering, those steps become very critical to the process as well. Traditionally, what we would be looking at is, in the case of a classification model, you'd be looking at models, a few of examples are shown here, things like logistic regression, naive Bayes classifiers, k-nearest neighbors, random forest, neural networks, etc. And we'd have to probably either use our past experience or do some research to find out which of these models may be most applicable to the outcome that we're trying to predict. And then we would go through some steps to test different models and measure the results, one against the other. Some of the tools that we use in that process, we're actually showing one here called RStudio, which allows us to program in the R statistical language. We also have other tools like Python and other tools that we would traditionally use to build these data sets, build the features, and then go through the model fit and training and verification steps. That's the traditional way. What we have with AI, and we'll do a brief demo of H2O Driverless AI. What we have with AI is it allows us to go through some of those steps much more efficiently. So we can gain insights quicker, we can achieve greater accuracy, and we're able to ultimately get to faster results for the outcome that we're trying to seek. So with that, I'm going to jump over to a quick demo. So what we're looking at now is a little bit of an eye test probably, but what we're looking at is a number of data sets that we've loaded into Driverless AI. And what I'm going to do is I'm just going to open the first one as an example. So we'll look at some training data. And it's pretty easy to get data into Driverless. You basically create, from the most simplest standpoint, create a CSV file, and you can upload it directly. And then what you're looking at is kind of a visual representation of the data that I uploaded. So what we're able to do is quickly look through the different features that we've loaded, the different columns of data, the variables, as an example here, a first size, maybe an average size purchase, distinct sizes purchased, etc. And we're able to get a feel for what's going on in that data set, basically. So in this case, I've got 476,000 values. I can look and quickly spot if there are missing values that we need to be concerned about. Maybe look at the ranges between the min and the max values, averages, etc. So it helps me understand if the data that I uploaded is truly, what I was expecting to get, and it points me into some areas that I may want to dive into a little bit more. So I might look at this, for example, and decide if I have a normal distribution, or I might look at other columns and decide that I've got some type of skewness or a need for log transformations, that type of thing. Once I have a feel for that data, I can then run some auto visualization capabilities within Driverless, and it will let me look at some additional details. So some of these plots are interactive. There may be specific recommendations, for example, that I can look at. In this case, one of the variables is recommended that we take a log transformation, and we can step through the different recommendations that Driverless is making and then decide if we need to take some extra steps to cleanse the data. Or there's also interactive plots we can look at that can help us look at things like correlations between variables and understand if we may have some variables that should be dropped or changed in some other ways. So this makes it very easy for us to get some quick insights on the data side. And then when we jump into an experiment, this is where we actually fit a model. So what I'm going to do is I'm going to open one up that's running right now. I actually kicked this off about 10 minutes or so ahead of the presentation today. And what we're looking at is we have, over on the left-hand side, I know there's a lot of content here, and again, apologize if it's difficult to read, but I'll just talk through a couple of things. What we're looking at is I've uploaded a data set with 340,000 rows of data and 61 columns. And what the model is doing is it's going through, if you look in the center here, it's going through and it's scoring a number of different models. So it's iterating through, it's trying different models. It's taken those initial 61 features and it's basically created 4,500 of its own features. So this is where AI comes in extremely handy, because it just wouldn't be practical for a data scientist to go through and build those types of features manually. So Driverless is going to make that process easy. It's also going to show us, as it iterates through each of these different models, it's going to refresh what we're looking at down below here. So it's actually showing us the variables that it believes at the moment are most important to the model. And over on the left-hand side, it will show us the overall score, the model that it's currently using. In this case, it's using an XGBoost model. And we can look back through the history by me selecting a different one of these points. You'll notice in the center that the variable importance will change. So it's showing how this variable importance list changes as the model evolves. Ultimately, what we want to see is what you're looking at over here on the right. And I'm going to step through a couple of these. These are interactive graphs. And so what we can look at, for example, on the gains side, this may be useful from a marketing standpoint. So for as an example, as I mouse over this graph, it'll show me that using about 30% of the most likely customers to churn, I can achieve about 85.2% of the cumulative gains. If I'm looking for more than that, I can move up to 40% and find out that with a 40% sample, I'm able to achieve 93.1% of the cumulative gains. So that can be a very useful chart. We talked a little bit about that earlier. The other one is the lift plot. And so what this allows us to do is if we were to, for example, take the top 10% likelihood of churning, we see that the cumulative lift is about 3.85 times higher than we would get if we would have just done a random sample. So the results that we're expecting to get are significantly better than a traditional random sample approach. As we move to the right, we can make a decision and decide, do we want to go to 20%? Do we want to go to 30%? As we move to the right, we're picking up a percentage of individuals that are maybe less likely, the score is less likely, but we can still see even at 30%, we're predicting to achieve 2.8 times better response than we would get through the random sample. The other graph that I want to briefly mention is the ROC plot. The ROC allows us to compare the overall fit of the model. And so for any business, what we're looking at is trade-offs. We're not going to be 100% correct. We're going to have, we're going to miss some cases. In some cases, we may falsely predict that someone's going to churn when they won't. And so that's what this plot helps us to understand, is how accurate is this overall model. So the higher the AUC score, the better fit for the model across the entire spectrum. And so, again, this is another interactive plot. So what we can do is we can mouse over, and this will allow us to look at things like the number of true positives that we would expect to get at that point in the model if we used that particular threshold, or the number of true negatives. And so what I'm going to do is I'm going to switch back to the presentation deck, because I know this can be a little bit difficult to read on this at this small scale. But this chart, which I also have in the presentation deck, is one of the important diagnostics that you should be looking at to gauge and evaluate the model performance. So what you're looking at on the left, it's actually called a confusion matrix. It might look complicated, but it's actually a pretty simple concept. What we're looking at on the top is the model prediction. So the model predicting some number of people that will not churn, and then some number of individuals that will churn. Then on the left-hand side, we're looking at the actual outcome. And so in this case, we've got the model predicting 11,936 individuals that it was expecting to churn, but when we looked at the actual outcome, it was actually wrong. That's a false positive. On the flip side, if we look down below, we had 30,980 that were predicted to churn, and they actually did churn. So what we can do is we can look at this simple confusion matrix, and we can understand, based on the threshold, which we can tune, we can decide whether this is an acceptable level of error. And the reason, just as an example, why we may be concerned with this and why we have to tune it is because in the case of that we're predicting churn when it's actually incorrect, that may result in us making an offer, maybe sending a $100 offer to somebody where we didn't necessarily need to do that. We spent money where we didn't need to. On the flip side, if I'm dealing with maybe a financial services industry or any industry where the customer lifetime value is particularly high, the cost of incorrectly identifying churn may not be the biggest concern. We may be more concerned with these false negatives, where we predict no churn and we actually lose a customer that had a very significant lifetime value. So again, for every business, we have to kind of look for that balance, and we can tune the model using that ROC curve that we looked at a couple of moments ago, and get things fine-tuned. A few of the model goodness of fit or accuracy metrics that I just wanted to point out. There are others in addition to this list, but a couple I just wanted to highlight quickly. Precision. So precision, just, we won't go through all of these, but just showing you how it's calculated, it's basically looking at the true positives on the left-hand side divided by the true positives plus the false positives. So in this case, it's giving us a 0.72 score, and that's basically the accuracy of predicting real churn. So when we're predicting churn, how accurate is the model at doing that? Recall is another metric, and this one is the risk of the model missing cases. And so, again, depending on the industry that your company is in, that may be, you know, the metric that you're more concerned about. Specificity is another metric to look at, and that's basically the accuracy of predicting no churn with the model. And then typically what we'll do is we'll look for some level of balance. So we'll compute an overall accuracy score, which I've shown down at the bottom, and that combination allows us to understand, you know, the goodness of fit of a given model. So what does this look like if we get into an actual case study? So in this particular example, we had a global CPG brand, and through some program analysis, we actually realized that there was a pretty high percentage of customers that had churned. It was a concern for the client. It's something that traditionally they had used rule-based selection criteria to drive their marketing campaigns. They were curious if a machine learning approach may help them improve their overall ROI. So what we did was we actually put together a retention campaign that used both approaches, and it tested one against the other. So we used the traditional rules-based selection criteria in one of the campaigns, and we tested that against a model predicted churn. What we found was that we definitely had success with the predictive model. We found our ability to improve the targeting offers was one of the most significant impacts. The redemption activity on the rule-based side was found to be actually 7 times higher to be redeemed by customers who wouldn't have churned anyways. So you're basically spending money on offers where it was unnecessary. When we looked at the overall ROI, we saw that the model, predictive model, actually achieved an 11% improvement in the overall ROI compared with the rule-based model. And with that, we'll open it up for questions.
Great. Thank you, Scott. Yes, please type in your questions in the questions tab. We'll give folks a few moments to go ahead and get those questions in. In the meantime, let me just pull up the slide here. Okay. So Scott, as soon as you start seeing questions come in, feel free to handle those and answer to your liking.
All right, sounds good. All right, one question that has come in is basically how do we create the initial feature set, or how do we select the variables that we are looking at to build the model? That, again, is going to vary tremendously from business to business. It also will depend on the type of data that you have available. Every company isn't going to have the level of demographic information. And so what I would suggest in that category is that, you know, one of the first steps is maybe to do an assessment to find out what data you have readily available. And part of the question as well is you're going to, a churn model isn't created once. It's something that you're going to build, and it's going to change over time. So you're going to want to look at data sources that you're going to be able to refresh at some interval. When you're looking at all the different variables that you have, it's like, how frequently can you get accurate data? What's required to transform that data? And then some of that is going to help you make those decisions, which variables are worth the effort, basically. And additionally, you may not know entirely out of the gate. It may be one of these things where you run an initial model and you find out what is important to the model, which variables are most important, you test some things. And that, as we saw with driverless AI, we provided 61 or so variables to driverless. Driverless basically transformed that into a couple of thousand variables. And then out of that, it probably will end up selecting a very small subset. So it may come back with even less than what we gave it initially. It may find 33 or so variables that are most important. That information you can then use to go back to your development process and kind of refine the steps. All right, just looking through some other questions. Another question. Were we successful in the first run of the campaign? If not, what are some of the challenges that we encountered during the first run? Good question. So I would say you kind of have to define first run, I guess, because what happens in the model building process is that you will build a number of features. You'll probably do a couple of trial runs on a limited set of features to see if you have signal in the data. Does it look like you're headed in the right direction? And so you're trying to get some directional input, and then you'll quickly iterate. And I would say with our first run through with driverless, absolutely, we were successful in the first run of that model. It was actually an interesting process for us. We were running this initially on a 21-day trial, and we took an existing model that we had developed. We loaded the data set into driverless just out of curiosity, and we were able to beat the AUC score that we had. It was a pretty decent AUC score, but we were able to beat it slightly in less than 24 hours. So that was extremely encouraging to us. And caused us to look further at the product. Let's see, another question. Outside of churn, what other predictive models do we recommend? Another good question. There's, as I mentioned in the presentation, one of the things that we have created as part of this process is the Smart Journey methodology. And so that model allows us, it's a multinomial classification model where we're looking at, now there's probably about 7 public stages. We've got a few additional stages that we use on the R&D side. But we're actually finding that driverless is helping us to improve our time to market with that whole process, to be able to predict more accurately the stages of engagement that each customer is in, and to be able to predict where they're going to be in the future. So that's looking at customer journey, looking at being able to predict where customers are headed is extremely valuable. So that would be another use case that I would recommend. One additional one is on the fraud detection side. Fraud is a difficult model to build, just because a lot of times the prevalence of people committing fraud is relatively small. It can have a big impact, however, on the financial side. And so due to the lack of prevalence, it can be very tricky to build that using traditional methods. With AI, we actually find that AI is pretty good at this. It's able to detect that signal and help you get to a more acceptable result faster. Another question: how many models were created? How many models were A/B tested before putting final models into production? This, I would say, we went through a series of steps. So in the traditional process, we probably went through, I think we started with maybe a random forest. It was relatively easy to fit, and then we looked at creating ensembles, using other types of models, things like XGBoost. I think we tried support vector machines in some cases, looking at certain types of data, and eventually putting together some of those models to create an ensemble. That process takes some time when you're doing that manually. With AI, you're able to remove yourself somewhat from that process. You still need a good data scientist that's going to oversee the process in general and understand the results. I would say that I think one of the key things to point out there is that AI and the model itself is basically handling the data science side of it. So it's trying different models. It's creating graphs that your data scientist can then interpret. But one of the things that you still need to be plugged into is you need somebody that understands your business, that can put those results into the context of your business. And that's where you're going to make trade-offs. You're going to decide, is it better for us to maybe err on predicting too many people who are likely to churn versus missing cases that are likely to churn? So hopefully that answers that. As far as the A/B test is concerned, like the case study that I walked through as an example, that was an example A/B test. We actually had control groups that were set up for each of the different campaigns, and ultimately we were looking at, is the traditional approach going to beat the other? And you may have to, statistically, you may have to do a number of A/B tests and to evaluate your results before you get to a conclusion. Let's see, another question. I think we answered that. Wondering how many models were created. Countwise, good question. Probably, again, the traditional approach that we used, we probably created about 8 different models. And you don't necessarily go through in all of those and spend a huge amount of time on each. You're trying to directionally determine which of the models seems to fit the problem that you're trying to solve. And again, that can take time. I mean, the traditional approach could take us, 2 to 3 months to work through, by the time you do the feature engineering and work through that entire process. What we found with using AI tools, that we're able to cut that probably in half. So you're still going to need to take the time to do the feature engineering side, or actually the variable creation, I should say. The feature engineering side of it will be cut down tremendously by the AI tools, as will the model selection process. How do we treat highly imbalanced data? Another great question. With a traditional model building approach, that's definitely something that needs to be considered. And what we did was, in the data sets that we used for the model, we actually tried to balance the data sets. So we tried to come up with a sample that equally represented the cases that we were trying to predict. One of the things that you have to be concerned with in that process is selection bias. So it's definitely something that needs to be handled manually and evaluated. The AI tools have some built-in heuristics to deal with that type of thing, so it doesn't require as much manual effort. And one of the tools that you could look at is the scorer that you select, for example. So there's scorers that are built into driverless AI, things like mean absolute error. You can look at AUC as a scorer. You can look at AUCPR that you might use for imbalanced classes. I think also that there's an option for MCC, Matthews Correlation Coefficient as well. So the documentation is actually pretty robust that's provided in the tool, and that would be something that I would recommend. I think it's available publicly if you wanted to read more on some of the I guess heuristics or the tools that driverless AI uses. Another question, do you think deep learning kinds of algorithms show some success for traditional use cases like churn? Absolutely. It's, I think it's an interesting question because I think when we started looking at AI, one of our assumptions was that maybe our business model wasn't the right fit. I mean, traditionally you hear about AI and deep learning being used for very complex problems like genetic sequencing or self-driving cars or applications that probably most of us don't deal with every day. And the other thing that you hear is that the data that you need is just huge, and in order to train these types of models, if you're trying to train a deep learning model, what you find is that while those things are true, what you find is that the data that we have today in many of our businesses is probably enough. And that was what we were quite happy to discover as we started using these tools. We do have very large data sets. And when I talk about large, I mean, we're dealing with, probably on the small end, we've got loyalty programs that have a few 100,000 members. On the upper end, we've got tens of millions of customers that are part of these programs. And as you can imagine, across that spectrum, they generate a tremendous amount of data. We end up with a lot of purchase transaction data. We've got market basket information. We've got redemption data. And when you look at all the variables and all the features that you can create out of that data, you end up with enough where you can get very significant results using deep learning types of algorithms in those types of use cases. Like churn as an example. But you could also be looking at, you could be looking at fraud was the other one that I had mentioned. We could be looking at predicting the customer journey. I could probably list off, 6 or 8 different applications that we could readily use. So looking through the questions here, looks like we've answered some of these other ones. A lot of questions coming in for sure. I believe, I'm just looking down through, it looks like some of these are duplicates. I believe we've addressed them all, unless there's any others that anyone wants to submit.
Yeah, I mean, we have a few more minutes if anybody wants to submit a final question or two. Now's the time.
We had one more question come through.
Okay.
How do we define the target? How do we define the target for phases of the customer journey? Let me see if I understand the question. As I understand the question, it's actually it's a great question, because it's one as we initially, when we did the traditional model, I think it's relatively easy to do. I mean, we look at past experience, we look at our experience within an industry, we look at responses to campaigns, that type of thing. We come up with some business rules that allow us to say, hey, here's what somebody who is an advocate, here's what they look like. Or here's what they look like if they're growing versus declining. So from a business rule standpoint, it's pretty simple. When you make the shift to artificial intelligence or to machine learning, it becomes a much, much more challenging problem. And I would say I like this question a lot, because I think this really shines a light on one of the most difficult parts of AI, which is to transform the data that you have and the problem that you're trying to solve into a format that the machine can then solve. And that isn't necessarily easy. So with this particular question, how do we define the target for the phases on the customer journey? What we needed to do is we needed to look at, some fundamental building blocks. So we had to start someplace. And so we're looking at, just as an example, grow. It's like, so how do you define someone that you are going to classify as grow? And there are competing rules, if you think about it. If you look across those 7 or 8 different stages, there will be competing rules where, an individual customer could meet criteria in multiple of those phases. So you have to define priorities as well. And ultimately, you have to answer questions like, how do I define grow? How do I define meaningful growth? Am I looking, for a given business, I might be looking over a period of weeks. I might be looking over a period of months. I might be looking at how to consider the impact of seasonal trends. I might be looking at, Q1 one year versus Q1 the next year. And all of those types of considerations need to be thought through. And then again, you have to then structure the data and the outcome, if it's grow as an example, you have to structure it in a way that then the machine can solve.
Great. Well, Scott, I think that would be our last question. So I want to say thank you, Scott, for taking the time today and doing a great presentation. I'd like to say thank you to everyone who joined us today as well. The presentation slides and the recording will be made available on our Bright Talk channel shortly after this webinar is concluded. Have a great rest of your day.